Welcome back to Maths with RP. We are going to use the method of substitution to solve problems involving integration. So the technique that is going to be used is substitution. So let us see some problems where such technique is useful. Sometimes even manipulation, how you bring it into a form by redefining what is given, also helps us to integrate the function much easier. So now if you look here, we have I equal to integral of sine of x minus a dx by sine x. This is integral of, okay, now I can write this as what is there in the numerator? Sine of x minus a. So I can write this as sine x cos a minus cos x sine a. By sine x. Okay. So the numerator I have written it as sine x cos a minus cos x sine a dx by sine x. Remember, x is a variable while a is a constant. So I simplifies to integral of cos a dx minus sine integral of sine a into cot x dx. Cos x by sin x is cot x. Now a is a constant, so cos a is a constant. Similarly, sin a is a constant. So when I integrate, it becomes cos a into x. Because this I can rewrite it as cos a into integral of dx minus sin a into integral of cot x dx. So integral of dx is x, so cos a into x minus sin a into integral of cot x. Integral of cot x was integral of cos by sin. Okay, so if I put integral of, for those who have forgotten, integral of cot x dx, how will you do? Integral of cos x by sin x dx. So if I put sin x as t, cos x dx becomes dt by t, which is log mod t plus c, which is further log mod sin x plus c. Cot x is cos x by sin x. If I put sin x as t, cos x dx becomes dt. So it is reduced to integral of dt by t, which is log t, so log sin x plus c. So this is minus sin a into log mod sin x plus c. So this is the value of the integral. The function is after integrating cos a into x minus sin a into log mod sin x. So I have just expanded, identified what is a constant and what is a variable. So just by simplification, I was able to integrate this problem. Are you able to understand? So here in this problem, the only technique I have used is simplification. And here I have used substitution. But you can, after you start doing problems, you need to remember this result. Integral of cot x is log mod sin x plus c. And why? The reasoning is by substitution. Is it clear? Can we pass on to the next problem? Now, I equal to integral of sine of x minus a dx by sine of x plus a. Now, this I can rewrite it as sine of x plus a minus 2a by sine of x plus a. Now treat x plus a as 1, probably a, and 2a as b. So it is of the form sine of a minus b, which is integral of sine a, which is sine of x plus a, cos b, which is cos 2a, minus cos of x plus a into sine 2a, divided by sine of x plus a. So this is the crucial step in this problem, is this. How to rewrite the numerator, whatever is in the bracket, using what is given in the denominator, so that I can bring it in the form of sine of a minus b, and which will help us in our simplification. So this is I equal to cos 2a is a constant. So cos 2a, sine of x plus a will get cancelled. So integral of dx minus integral of cot of x plus a, because cos of x plus a by sine of x plus a is cot of x plus a into sine 2a dx. Now sine 2a is a constant. This is cos 2a. Integral of dx is x. Now integral of cot theta we have seen is log sine. Log mod sine of x plus a this is a constant, you can take it outside, into sine 2a plus c. So the numerator, we are writing it as x plus a minus 2a. So capital A is x plus a, b is 2a. Sine of a minus b is sine a cos b minus cos a sine b, where a is x plus a, b is 2a. Now simplifying, here sine of x plus a gets cancelled, giving you cos 2a, but cos 2a is a constant. So cos 2a into integral of dx is cos 2a into x minus integral of cos of x plus a by sine of x plus a is cot of x plus a into sine 2a. Sine 2a is a constant, you can take it outside the integral. Integral of cot theta is log sine theta. So log mod sine of x plus a into sine 2a plus c. So this is the value of the integral. Integral of sine of x minus a by sine of x plus a dx. Is it clear? Now we have I equal to integral of cos x dx by 1 plus cos x. So I have taught you now one kind of manipulation or one kind of technique, writing the numerator using the denominator. So how can I write here? So I can write the numerator as 1 plus cos x minus 1 by adding and subtracting 1 by 1 plus cos x dx. This is integral of 1 plus cos x by 1 plus cos x will give me dx minus integral of 1 by 1 plus cos x dx. Now I will be equal to x, integral of dx is x minus integral of 1 by 1 plus cos x is 2 cos square x by 2 dx. This is further x minus half into integral of secant square x by 2 dx. Integral of secant square theta is tan theta. So this will be x minus half into integral of secant square x by 2 will be tan x by 2. Since the coefficient of x by 2 is half, and since this is integration, which is the inverse process of differentiation, I am dividing by half plus c. This half gets cancelled, giving you x minus tan of x by 2 plus c. So The manipulation that we or the technique that we are using is adding 1 and subtracting 1, splitting it into two integrals. This is very simple, direct. This you have to use the formula for 1 plus cos x, 2 cos square x by 2. If I use substitution, I can write x by 2 as t, then dx will be 2 dt. I should not be doing that at this stage because I've already done many sums of that type. So this is secant square x by 2. You should now, you have reached a stage where you can write this directly as tan x by 2 by half. Now there's already another half, so it gets cancelled, giving you x minus tan of x by 2 plus c. This is again a problem which involves manipulation. Okay, so we have integral of dx by sine of x minus a into sine of x minus b in the denominator. The technique I am going to use is, I am going to multiply and divide by sine of b minus a. I will tell you why this technique is going to work. Okay, because then I can write this b minus a in terms of x minus a and x minus b. That is what we have done in the earlier problem also. So this is 1 by sine of b minus a is a constant. So 1 by sine of b minus a into sine of b minus a, I can write it as sine of, okay, x minus a minus x minus b divided by sine of x minus a into sine of x minus b dx. Okay. Now x minus a minus x, xx will get cancelled, minus a plus b, which is b minus a is what we have here. Now what is the use of writing like this? Now this is of the form again sine of a minus b, which is again 1 by sine of b minus a integral of sine a cos b. Cos b is cos of x minus b. Okay, minus cos a sin a cos b minus cos a sin b. Cos a is x minus a, sin b is sin of x minus b divided by sin of x minus a into sin of x minus b. Now this is, I am going to simplify it further. Sin of x minus a, sin of x minus a gets cancelled. Cos of x minus b by sin of x minus b is integral of cot of x minus b. Okay, minus, now which will sin of a x minus b will get cancelled. So cos of x minus a by sin of x minus a is cot of x minus a. So minus cot of x minus a dx, which is, okay, integral of cot x is log sin x. So this is log mod sin of x minus b minus log mod sin of x minus a plus c. So this problem involves manipulation. You have to remember the which is a technique of multiplying and dividing by sine of b minus a. The reason being, sine of b minus b can be expressed in terms of sine of x minus a and sine of x minus b as follows. And that will help us to simplify, because you can use the formula for sine of a minus b as sine a cos b minus cos a sin b. Then it is reduced to the form integral of cot theta, which we know. So cot of x minus b minus cot of x minus a. both the integrals we know we can write directly as log of sine of x minus b minus log of sine of x minus a. Are you able to follow? Plus c, which is a constant of integration. Now let us look at this sum. 1 by x square into sine of 1 by x dx. Okay. So let us let 1 by x be equal to t. Let 1 by x be equal to t. Then minus 1 by x square dx will be dt. So which is I equal to integral of sine square. What is 1 by x? T. What is dx? Dx is dt. See, what is dt? Minus 1 by x square dx is dt. So 1 by x square dx will be minus dt. Okay. Now how are we going to integrate sine square t? So this is minus integral of sine square t is 1 minus cos 2t. Remember the formula for cos 2x is 1 minus 2 sine square x. So 2 sine square x will be 1 minus cos 2x, or sine square x will be 1 minus cos 2x by. So from here sine square x will be 1 minus cos 2x by 2. So here you have t. So 1 minus cos 2t by 2 dt. This is half minus half into t plus half into integral of cos t is sine 2t by 2 plus c. This is in terms of t, while the original function is in terms of x. So we'll write t in terms of x. What is t? T is equal to 1 by x. So minus 1 by 2, t is 1 by x plus 1 by 2 sine of 2t, 2 by x. Right? So 1 by 4 into sine of 2 by x plus c. Minus 1 by 2t, this becomes plus, so 1 by 2. When you integrate cos 2t, I will get sine 2t by 2. That is why there are 2's here. So 2 into 2, I have multiplied and put 4 here and substituted back for t as 1 by x. If t is 1 by x, 2t will be 2 by x. So this is the value of I. So these techniques are something that you need to master. So integration is not, you can't just like differentiation, there is nothing like product rule or quotient rule, which directly when you see product of functions you can apply, or quotient of functions you can apply. Integration is purely by developing a mathematical intuition about what technique to use, so that you can reduce it to a form that you can recognize. So that is the main aim. So what technique to use? How can I reduce it to a form for which I can write the value of the integral? Okay. So here the technique that has been used is method of substitution. 1 by x equal to t minus 1 by x square dx is dt. So I becomes minus sine square t. Sine square t I can write it as minus of 1 minus cos 2t by 2 dt. Then minus half into t plus half into sine 2t by 2 plus c, which is, then I substituted for t as 1 by x. Is it clear? Please practice these problems. So once you get an develop that the idea of where you should use such techniques, then solving problems in integration will become quite simple. So until we meet next time, we have come to the end of the session. Until we meet next time, it's goodbye. Please practice these problems again and again until you get the hang of the technique. Wishing you all the very best. Goodbye.